In April of 1815, a mountain on a remote Indonesian island exploded with such staggering force that the blast was heard. Nearly 1,000 miles away, mistaken by regional rulers for cannon fire from an invading army. What followed wasn't just the deadliest volcanic eruption ever recorded, it was a catastrophe so massive it changed the weather across the entire planet for 3 straight years, triggered famines on continents thousands of miles away, and eventually killed more people than any other single volcanic event in human history. And here's the part that should genuinely concern you. The volcano responsible is still standing. Today, still active, and scientists say an eruption of similar scale isn't a matter of if, but simply a matter of when. The volcano was Mount Tambora, located on Sumbawa Island in what is now Indonesia, and prior to April 1815, it had shown essentially no signs of significant activity for thousands of years, giving nearby communities almost no warning of what was building beneath the surface. The eruption began on April 5th, with tremors and early pyroclastic flows, but the true cataclysm arrived on the evening of April 10th, when the mountain's summit blew apart in what witnesses described as a cacophony of explosions. The blast launched an ash column an estimated 20 miles into the atmosphere, while rivers of boiling liquefied rock, technically known as pyroclastic flows, raced down the volcano's slopes at speeds that gave nearby villages virtually no chance to escape. Within hours, entire settlements simply ceased to exist. Forests across the region were incinerated almost instantly, and massive flows of molten rock plowed directly into the surrounding ocean, triggering explosive steam blasts and a moderate tsunami that added yet another layer of destruction to an already unprecedented disaster. The sheer physical scale of what Tambora ejected is difficult to comprehend, even by the standards of history's largest natural disasters. The eruption expelled somewhere in the range of 100 to 150 cubic kilometers of gas, ash, and pulverized rock, the equivalent of roughly 140 gigatons of material blasted into the sky and across the surrounding landscape. The mountain itself was physically reshaped by the violence of its own eruption, its height reduced from an estimated 14,000 feet before the blast down to roughly 9,000 feet afterward, leaving behind a massive caldera nearly 4 miles wide and over 3,600 feet deep where the summit used to stand. Ash fell so heavily across the region that the sun disappeared from the sky for days at a time in areas closest to the volcano, while houses hundreds of miles away reportedly collapsed under the sheer accumulated weight of falling ash debris. The immediate death toll on Sumbawa and neighboring islands was devastating on its own, with historical estimates for direct deaths from pyroclastic flows, ashfalls, and the tsunami ranging anywhere from roughly 10,000 up to as high as 71,000 people, depending on which historical account and modern research methodology you consult. But it's the eruption's secondary effects that transformed Tambora from a regional catastrophe into what many historians now consider the deadliest volcanic event in recorded human history, combining direct casualties with the far larger number of deaths that followed from starvation and disease in the years afterward. Total death toll estimates commonly reach approximately 100,000 people, with some broader historical assessments suggesting the true global toll, once you account for famine and disease outbreaks connected to the eruption's climate effects, could have stretched into the tens of millions. Here's the mechanism behind that staggering secondary toll, and it's the part of this story most people have never actually heard. Tambora didn't just devastate the region immediately around the volcano, it injected such an enormous volume of sulfur aerosols into the upper atmosphere that it measurably cooled the entire planet for roughly 3 consecutive years. Author Gillen Darcy Wood, who wrote an entire book examining Tambora's global impact, has described the resulting period bluntly, explaining that the world got colder and weather systems changed completely across the globe for 3 full years following the eruption. That climate disruption produced what became known as the Year Without a Summer in 1816, a period so severe that snow fell across New England in the middle of July, with temperatures plunging into the 30s during what should have been peak summer warmth. Crops failed catastrophically across large portions of North America, Western Europe, and parts of Asia, triggering widespread famine in regions that had absolutely no connection to the volcano itself, and, in most cases, no idea a distant eruption was even responsible for their suddenly failing harvests. Perhaps the most chilling secondary consequence involved disease rather than famine directly. Researchers studying Tambora's broader historical impact have connected the eruption's climate disruption to the emergence of a new, more virulent strain of cholera that developed in the Bay of Bengal region during this same period of global climate chaos. Cholera existed before Tambora's eruption, but the volcano's dramatic cooling effect on regional weather patterns is now believed to have contributed directly to the conditions that allowed a new, more dangerous strain to emerge and eventually spread across the globe, ultimately contributing to a series of cholera pandemics that killed millions of people over subsequent decades. If you include that pandemic connection in the eruption's total human toll, some researchers argue the true death count attributable to Tambora climbs into a category almost impossible to fully quantify. i.e., this single geological event in Indonesia ultimately reshaping global health and mortality patterns for years afterward. For comparison, it's worth understanding why Tambora remains relatively unknown to most people today, despite its almost unimaginable death toll. The 1883 eruption of Krakatoa, another Indonesian volcano, is far more famous in popular culture, largely because it occurred at a point in history when telegraph communication and early photography allowed news of the disaster to spread rapidly around the world in a way that simply wasn't possible in 1815. Despite that fame, Krakatoa was actually a weaker eruption than Tambora, and its death toll of approximately 36,000 people, while catastrophic in its own right, was considerably smaller than Tambora's overall toll. Mount Vesuvius's infamous destruction of Pompeii in 79 AD, meanwhile, one of the most culturally iconic volcanic disasters in Western history, claimed roughly 2,000 lives, a fraction of what Tambora ultimately produced. In short, the deadliest volcanic eruption in recorded history isn't the one most people have actually heard of. So could something like Tambora happen again? The honest answer from volcanologists is unsettling in its simplicity. Yes, eventually, it almost certainly will. Researchers at Munich Re, one of the world's largest reinsurance companies with a strong institutional interest in understanding catastrophic natural disaster risk, estimate that a volcanic eruption with truly global climate impact comparable to Tambora occurs, on a return period of roughly once every 250 years worldwide. Given that Tambora's eruption happened over 2 centuries ago now, the statistical window for another comparably massive event is very much within the range modern society should be actively thinking about, even though the odds of any single specific volcano producing that next catastrophic eruption remain individually very low. Tambora itself remains an active volcano. To this day, having experienced a smaller eruption as recently as 1967, and it periodically shows renewed rumbling activity that draws close scientific attention, most notably a stretch of increased seismic unrest in 2011 that prompted precautionary evacuation orders for nearby farmers, even though that particular episode ultimately didn't escalate into another major eruption. Tambora's story also opens the door to an even more sobering category of volcanic risk that scientists have spent decades studying: the phenomenon of supervolcanoes. As one science writer covering the topic for national volcanoes form mountains, while supervolcanoes erase them entirely, killing plants and animals for miles around in the case of standard eruptions, but threatening entire species with extinction through global climate disruption in the case of a true supervolcanic event. Tambora, despite its catastrophic global impact, doesn't actually qualify as a supervolcano by the strictest scientific definition, but it offers a genuinely useful real-world preview of the kind of climate disruption a true supervolcanic eruption could unleash, just at a smaller, though still globally significant, scale. The most closely watched supervolcano on Earth sits not in Indonesia, but in the United States, directly beneath Yellowstone National Park. Approximately 1 million people currently live within what scientists consider the immediate kill zone of a major Yellowstone eruption, with roughly 2 million more living in the surrounding region that would face severe life-altering impacts. Unlike Tambora, which is a conventional stratovolcano, Yellowstone sits atop a massive underground magma chamber, capable of producing an eruption potentially thousands of times more powerful than Tambora's already devastating 1815 event. Volcanologists studying Yellowstone consistently emphasize that the supervolcano shows no current signs of an imminent eruption, and that geological timescales for events like this one are typically measured in tens of thousands to hundreds of thousands of years, rather than anything resembling a human lifetime. But its mere existence underscores just how much more catastrophic volcanic risk can become once you move beyond even history's deadliest conventional eruptions. Indonesia's broader volcanic landscape also deserves context here, since Tambora wasn't an isolated geological anomaly, but rather part of one of the most volcanically active regions on the planet. The country sits directly along the Pacific Ring of Fire, the horseshoe-shaped zone circling the Pacific Ocean responsible for the overwhelming majority of the world's earthquakes and volcanic eruptions. And Indonesia's collection of roughly 17,000 islands gives it more active volcanoes than any other country on Earth. That geological reality means Tambora, devastating as it was, represents just one entry in a much longer ongoing history of significant volcanic activity throughout the Indonesian archipelago, a pattern that continues to this day and shapes disaster preparedness planning across the entire region. Modern volcanic monitoring around Tambora specifically continues on an ongoing basis, reflecting just how seriously scientists take the possibility of renewed significant activity from a volcano with this particular history. Indonesian volcanologists maintain continuous seismic monitoring stations around the mountain, tracking any changes in ground deformation, gas emissions, and small-scale tremor activity that could signal building pressure within the magma system below. This kind of sustained, long-term monitoring represents exactly the sort of advanced warning capability that simply didn't exist in 1815, when communities near Tambora had essentially no scientific framework for understanding what the mountain's early tremors in early April actually meant before the catastrophic main eruption arrived just days later. If content like this helps you understand the massive, often overlooked forces that have shaped human history, go ahead and like this video and subscribe, because we'll keep digging into the natural disasters that changed the world, but rarely make it into most people's historical knowledge. The genuinely reassuring news, according to experts studying this exact scenario, is that a repeat Tambora-scale event today would almost certainly produce a far smaller direct death toll than the original 1815 catastrophe. Modern volcanic monitoring technology allows scientists to detect the warning signs of a major eruption building with a level of reliability that simply didn't exist 2 centuries ago, which means large-scale evacuations, like those successfully carried out during the 1991 eruption of Mount Pinatubo in the Philippines, are now genuinely possible in ways that could save enormous numbers of lives that would otherwise have been lost. The large-scale famines and disease outbreaks that made 1816 the year without a summer would also likely be far less catastrophic today, given how dramatically global food distribution networks, agricultural resilience, and medical infrastructure have advanced since the early 19th century. But the underlying climate disruption itself, the global cooling, the disrupted weather patterns, the agricultural stress across regions, with no direct connection to the eruption, that part of the equation hasn't changed nearly as much as our ability to protect individual human lives. Which means a modern Tambora would still represent one of the most significant natural disasters the world has faced in generations, even with every advantage modern science and preparedness now bring to the table, a sobering reminder that some forces of nature remain far bigger than any single country's ability to fully control,